Okay, going to do a basic review of how stars form and how they work. The first stage is you have a nebula, which is a giant dust cloud, which eventually collapses by a shock wave or something else happening to it. And it gets smaller and smaller over time. There's usually a rotational component, and then the gravity from the interior, from the center of mass, forces the mass on the outside to come in, and this creates pressure on all the layers underneath of it. And the star generally starts creating energy from nuclear fusion, which starts off with a hydrogen proton combining with an electron to form a neutron, and this combines with another hydrogen to form deuterium, which is a heavy form of hydrogen, which is a hydrogen proton and a neutron, plus a neutrino, which is a small, almost massless particle, plus a positron, which is an electron with a positive charge. Then the hydrogen with the proton and the neutron combines with one with just a proton, which forms helium-3, which has 2 protons and 1 neutron, plus it also gives off a gamma. And then the two helium-3s combine, and then give off 2 hydrogens, and you get a helium with 2 protons and 2 neutrons. There are other chains to this proton-proton cycle, such as when helium combines with beryllium, and the beryllium then decomposes and gives off a gamma ray, and then beryllium plus an electron creates lithium and a neutrino, and then the lithium plus helium gives off 2 hydrogen 4s. And this continues until the hydrogen is used up, and then the star goes burning helium, and then further and further. And then when it starts combining iron, there's no energy that comes out of this reaction. So the star keeps squeezing and squeezing and squeezing, and it's only going to squeeze so far, and then it gives off a big explosion, and that's what causes a supernova. And hopefully I didn't boggle that up too much, but just to give the idea that the pressure inside the star is immense for all this to happen. It's ruled by PV equals nRT. And so in the very core of the star, since the pressure gets so high, the temperature increases to like 15 million degrees Celsius, and that's why these reactions happen, right? And then the temperature the energy they give off is translated to temperature, and that forces the star to expand. And a star is basically a balance between the force from the heat coming out and the gravity and pressure coming in. And as stars burn heavier elements, they give off more energy, and they get heater. They expand more and more. So that's where you get like stars like Betelgeuse, and that's why every time Betelgeuse gets in the news, is that the star may be close to a supernova. So when it starts getting darker, this is when they think it's about to collapse into itself and explode. Thank you for listening to this, and have a good day.